Today we're going to learn about the scientific method, and then we're going to apply the scientific method and also apply like dissolves like general rule to predict solubility. So first let's look at the scientific method. The scientific method, we first have to find a problem, and then we have to define that problem, and then we make a prediction, right? Also known as a hypothesis or educated guess. And then from that hypothesis, we make observations and we test the hypothesis by conducting experiments. So we make these observations, we organize the data, we interpret the results, and then if the results and the observations support the hypothesis, then we draw conclusions and we publish the results. If they don't, then either we have to revise the experiments or we have to revise the hypothesis, and then we do the whole thing again. We make the observations, organize the data until the experimental data aligns with the observations and our hypothesis. Okay, so we're going to use this principle in trying to understand and being able to predict and observe solubility, right? And so the first thing we're going to do is we're going to apply the like dissolves like general rule. And as we just mentioned, we saw that hexane is a nonpolar molecule because it is symmetrical, has a symmetrical electron cloud. So it is nonpolar. There's no charge separation. We saw for water that water is polar because there is charge separation. There is an asymmetric electron cloud. All right, so what we're going to do in test tube A is I'm going to add hexane to water, and what I want you to do is draw the test tube and predict what will happen when I add hexane and water. So again, hexane is just lighter fluid, so it's a petroleum product, just like the material that you put in your car to come to work. And we all are very familiar with water. So in your everyday life experience with petroleum, whether it's lighter fluid or gasoline or reading about the Exxon Valdez oil spill, you know a little bit about petroleum and water. So use your knowledge, your previous knowledge, your experience, and make a prediction by drawing a test tube and figuring out, are these going to dissolve in each other? Are they not going to dissolve in each other? Are there going to be layers? Are there going to be colors? So take a moment and do that. Okay, so I'm going to add hexane to this test tube, which I call test tube A. So that is hexane. And now I'm going to add water. So hexane is colorless and water is colorless. So it's going to be a little tricky to see what's happening, but can everybody see what's happening? As I add water, which layer is growing? Right? Which layer is growing? So whenever you're not sure what layer is on top of another layer, and if one of the solvents happens to be water, just add more water and see which layer grows. Whichever layer grows is the water layer. So in this case, you can see that the water is on the bottom and the hexane is on the top, and no, they do not mix, right? So let's fill out this chart. Draw the test tube. So what we saw a test tube, right? And as I added more and more water, the bottom layer increased, right? So hexane is on the top. So there are two layers, right? Both of them, these are colorless. Are these soluble or not soluble? Well, we saw a very distinct layer. So actually it's insoluble. And is one more dense than the other? Yes. The heavier one that's on the bottom would be more dense. So the more dense is water, is more dense. And the lighter is hexane, and we say that's less dense, right? And then you can make your notes about the observation. So that is test tube A. Test tube B, we want to add water and potassium permanganate. potassium permanganate is a purple salt, but everything that you know about table salt, sodium chloride, is going to be true for potassium permanganate in this experiment. So the only reason why I'm not using sodium chloride in this experiment is because it's colorless. So I'm just using this purple salt. So what we're going to do is we are going to add a purple salt, which is very much like sodium chloride, called potassium permanganate. And this is going to be in test tube B. So I'm just going to add a little bit of potassium permanganate. And I don't know if you could see, but it's this dark purple salt. So I'm going to add a little bit. And then I am going to add some water to test tube B. Right? And let's see what happens. So what is happening here? Okay, so if you draw this test tube, what would it look like? How many layers does it have? It has one layer. So what this test tube looks like is it has a mixture of a purple solution, and that purple solution is purple salt water, right? So you would say that this is soluble, right? And before we added the water, you can see that the solid salt was at the bottom. So actually the solid salt, right, the potassium permanganate, is more dense than the water, right? The water is less dense in this case, right? But when we mix them together, they are soluble. So again, this goes back to like dissolves like. Water is, do you remember, is it polar or non-polar? It's polar. And the general rule is that polar materials dissolve other polar materials and many salts. And so this follows that general rule. The polar water molecule solubilizes the salt, the purple salt. All right, now we're going to look at C. So for C, I'm just going to add test tube B, which is potassium permanganate and water. Sometimes we just say aqueous potassium permanganate, to A, which is water and hexane. So let's predict what will happen. Okay, predict. And then after we predict, again, I'm going to add test tube B to test tube A, water and potassium permanganate. And so when I do that, what can you see? What is happening here? Well, I gotta let it separate. Okay, so now the question is what's on top and what's on the bottom? So again, whenever you're confused, you can just add some water, right? And you can see which layer is growing, the bottom layer. So since the bottom layer is growing, that means that the purple salt is in the water and the hexane is on top. So again, if we drew this test tube for this one, right? Sorry, I'm running out of room here. The purple aqueous purple, right? And then you have the hexane on top. So this is hexane. And this is the purple salt, potassium permanganate plus water, right? So how many layers did you get? You got 2. And again, it follows this rule. Hexane is not soluble in water, and it doesn't solubilize salt. And water is also known as a universal solvent. Not that it dissolves everything. We just saw it doesn't dissolve hexane, but it does dissolve other polar materials and salts, generally speaking. Okay, so now what I'd like you to do is make predictions for hexane and potassium permanganate, and I will show you I will do the demonstration. So we're going to add hexane to this test tube, and then some potassium permanganate. And before I do, you should, from the results of A, B, and C, you should be able to predict what will happen when I add the purple salt, or a little bit of the purple salt. Right? So it's either going to dissolve or it's not going to dissolve. So you should make that prediction and then watch the result. And that is the result. And hopefully you predicted that this non-polar hexane does not dissolve this purple salt known as potassium permanganate. Okay, so that was test tube D. Did everybody get that? All right, now we're going on to test tube E, which is hexane and iodine. Now, we know what kind of molecule hexane is. We said it is a non-polar molecule because it has a symmetrical electron cloud, right? And iodine is this molecule here, right? So do you think that the electron cloud is symmetrical or asymmetrical? Hopefully you can see that it is symmetrical. So if it's symmetrical, there's no charge separation, and therefore you will assume that, or predict, that iodine will be nonpolar because there's no charge separation. So let's take a little bit of iodine. And so we said the hexane is polar or nonpolar? Nonpolar. We said the iodine is nonpolar, right? Because they both have symmetrical electron clouds, no charge separation. Like dissolves like. So one would predict that these two materials will dissolve in each other. And they do, right? Like dissolves like. So iodine, again, is nonpolar, symmetrical electron cloud. Hexane is nonpolar, symmetrical electron cloud. Like dissolves like, you would predict that they would be soluble. So you can complete E. Okay, test tube F is water and iodine. So we're going to take some water. Oh, this is water. And we said water is a polar molecule. So if water is a polar molecule, that means it has an asymmetric electron cloud. And now we are going to add iodine, right? So here's some iodine. And we said iodine is a nonpolar compound because it has a symmetrical electron cloud. So if this water is polar and this iodine is nonpolar, we would predict that they should be not soluble because like dissolves like, and they're not alike. So this is test tube F. The last test tube is I am going to add test tube F to the contents of test tube E. So here's test tube E. So again, test tube E is hexane and iodine, and this is water and iodine. So predict what's going to happen. Okay, so I'm adding the water and the iodine to the iodine and the hexane. And again, hexane and water don't mix. Water and oil don't mix, right? And since iodine is nonpolar and hexane is nonpolar, the iodine is solubilized in the hexane, which is on top. So please complete this table for test tubes D, E, F, and G. Thank you.